Railways, the vascular system of America. When trains were introduced to the United States in the early 19th century, the world of transportation changed forever. Railways began dominating the country, carrying people and cargo with record speed. Today, 40% of the world's freight cargo is still transported via trains. From early locomotives to modern-day trains, valves work behind the scenes to ensure safety and efficiency in the railcar industry. Apollo offers a selection of valves, fittings, and automation products to meet a variety of needs in both the industrial and commercial construction markets. One of the most essential components in industrial process valves are the pressure-containing castings. Apollo challenges the status quo by producing steel and alloy castings in its own, state-of-the-art 300,000 square foot facility in Conway, South Carolina. This valuable company asset allows Apollo to differentiate its industrial products with shorter lead times, factory responsiveness, and consistent, high-quality materials. Let's take a closer look at the process of manufacturing these castings, as well as some of the in-house capabilities that Apollo uses to guarantee the materials it produces are of the highest quality. Apollo ball valves are the reliable workhorse in a variety of applications throughout the transportation industry. Designed and built in Apollo's ISO 9001 registered Conway facilities, these valves feature corrosion-resistant bodies and internal components that offer extended service life. They are manufactured to stringent specs and approved by the Association of American Railroads, AAR. We will follow this two-piece threaded quarter-turn ball valve, as well as this split-body flanged valve, as they move through their respective casting processes and onto machining, assembly, and testing. Superior valve construction begins with either the investment or air-set casting process. For smaller valves, a lost wax investment casting process is used. Investment cast valves are produced from 1/4 inch up to 2 or 3 inch pipe sizes depending on the particular model. Once a valve has been designed by engineering, 3D models are created utilizing CAD. From there, one of Apollo's experienced mold makers will create an aluminum wax injection mold using CNC machining. Specifically engineered wax is melted and injected into the void of the mold cavity to produce a dimensionally duplicate wax replica of the finished product. The wax molds are carefully removed from the patterns and inspected. Small imperfections are removed. This is an important process because imperfections in the wax mold can cause defects in the final casting. After the inspection, the valves are bonded to a wax tree with an adhesive wax. The trees are then hooked to a custom automated mold handling line. At this station, several types of proprietary ceramic slurries are prepared, which will eventually create the inner and outer shell layers of the mold. The robots in this room apply the slurry coatings to each one of the wax trees. They are kept on a strict schedule, constantly dipping, drying, re-dipping, and re-drying the trees in a carefully regulated environment to create defect-free ceramic molds. Any deviation can result in mold cracking. Once the molds have completed their dipping and drying cycles, they are moved to an even more strictly climate-controlled room to complete the drying process. After the ceramic molds have finished drying, they are sent to the autoclave. This is the first time a person has touched these molds since they were assembled. The autoclave melts the wax inside the ceramic molds without damaging them by rapidly introducing high-temperature steam from an accumulator chamber. Now that the wax has been removed, the molds are almost ready for pouring. To prevent thermal shock cracking, the molds must be preheated in this kiln to high temperatures before the molten steel is poured. Molten steel is carefully poured into the ceramic mold. Apollo sources all ingot for its carbon, stainless, and specialty alloy steel castings from 100% U.S. domestic sources. After pouring is complete, the valves are control-cooled and solidify within the protective mold shell. Once the mold has cooled to safe temperatures, it is ready to be removed from the casting. The castings are then removed from the tree. Next, they move to the ceramic leaching, where any of the remaining ceramic from the mold is removed. Castings then go to the grinders, where the tree connection is ground off and the castings are inspected. The final step in the foundry is to subject the castings to heat treatment. This is beyond what is required by ASTM standards. Apollo Valves utilizes specially designed vacuum furnaces to ensure pinpoint thermal accuracy and eliminate surface scaling during the entirety of the heat treatment cycle. This heat treatment procedure is critical in ensuring that the corrosion resistance and mechanical properties produced are consistent and highly repeatable. The castings are high-temperature solution annealed and quenched to lock in the desired microstructure that prevents segregation-induced corrosion sensitization. Apollo operates a large fleet of CNC machines capable of a number of various operations. Now that the steel components are finished, let's discuss some of the soft material components that go into the finished valve. Seats and seals are also manufactured in Apollo's facilities. Once the components are complete, they are ready to be assembled into finished valves. Valves that need to meet the specific requirements of AAR are assembled in this dedicated manufacturing cell. Many of the investment cast valves used in the railcar industry are two-piece valves like this 76F full-port valve. After the valve is assembled, it moves to the next station where a tack weld is applied. AAR requires that several tack welds are applied to the connection of the body and the retainer of certain valves. This adds an additional level of protection against this connection separating due to vibrations common in railcar applications. Finally, the valves are hydrostatically tested in compliance with AAR procedures. When the testing is complete, the valve receives a nameplate and is sent to be packed and shipped to the customer. For larger size castings, Apollo uses an airset process. Airset casting begins with the design of the pattern. This is assisted by MagmaSoft solidification modeling and building tooling to create the cavities in the sand for metal to flow through. The 3D impression molds are made from wood and abrasion-resistant polymers. Resin-impregnated sand is mixed with engineered sand system additives before filling first the top, or coat, and then the bottom, or drag, of the sand mold. The operator then carefully levels the box, as this will either become the top or bottom of the fully assembled mold. After the resin is allowed to harden, the mold has now become one solid piece. The piece is then flipped and removed from the box. The internal passageways of the mold are carefully sprayed with an inert ceramic slurry, similar to that used in the investment casting process. This seals small voids in the sand and helps give the casting a smoother finish. The freshly applied slurry is then control dried using ultraviolet light. On an auxiliary line, workers are using the same process to prepare the sand cores. These will be placed in the mold cavities to create the internal passageways to the valve body or retainer. The cores are first prepped with a ceramic sealing slurry to provide a smooth casting surface. Similar to investment casting, molten steel is then poured into the mold. However, unlike investment casting molds, these sand molds can handle the thermal shock from pouring. Once allowed to solidify, the molds are then dumped into the shakeout unit, which will break apart the sand, where it will be cleaned and reused on future molds. For the larger casting produced in the airset process, metal shrinkage must be prevented with the addition of large feeders, similar to how the tree fed the investment castings. These feeders must be removed with a plasma torch so that the castings can proceed to the next step. All the feeders will be remelted, refined, and poured into future castings. Like the investment casted components, the larger airset castings will also receive heat treatment, enhancing the product's uniformity as well as corrosion and mechanical properties. This machining cell is creating the raised face flange onto the casting so that it will mate with the piping. Valves that require AAR certification are assembled in the cell, with its own designated hydrostatic testing setup. Every valve is tested individually to ensure that they meet the highest quality standard. For almost 200 years, trains have provided the heartbeat to America by dominating shipping, travel, and culture. Apollo is proud to offer products that help keep the railcar industry on the right track.